Okay, so here we are on Stats and Mechanics Year 1, Chapter 7, Hypothesis Testing. Question 4. The proportion of defective articles in a manufacturing plant has been found from log experience to be 0.1. A random sample of 50 was taken in order to monitor the production. The number of defective articles was recorded. Use a 5% level of significance to find the critical regions for a two-tailed test of the hypothesis of 1 in 10 articles has a defect. So we are looking at a x part A. We are looking at x being binomially distributed. We have taken a sample of 50 and we have a probability of 0.1, 1 in 10. We are going to have a hypothesis test of null hypothesis. Probability will equal 0.1, and then we have an alternative hypothesis of it being 0.1 but not equal, and we are working 5% two-tailed. So we are looking at 2.5% in each one, which is 0.025. So, coming on to here, 1 in 10, find the critical region. At what point are we happy to say that what we have is correct? Okay, so we need to do two tests. We need to do one test for the lower bound and one test for the upper bound to find it. So, probability that x is less than or equal to, let's start with 5, okay, is equal to, and we need to see if that is less than 0.025, okay. So if I come on to here and pull up a calculator, okay, let's come down here to the distributions, over to the binomials, and we are going to have the number of trials set at 50, and we have the probability set at 0.1, and then we start looking for the probability, and I said I would start at 5. Okay, so at 5 I've got 61%. That's huge. Okay, so that's a long way off 0 to 5. Okay, so coming back here, that was 0.61. No, so that was too big. Let's look at the probability of x being less, and let's drop it down to, I don't know, 2. See what that is. Is that less than 0.25? Let's have another look at the calculator. I dropped it to 2, didn't I? Put it in. 11%. No good. Okay. 0.11. No. So probability of x being less than or equal to 1. Then we will have a look at next. Running out of options here. Okay. And so putting it in as 1 equals 0.03. Now that is still too big. Okay. 0.03. Okay, what was the other decimal point on that? Incidentally, 337. Okay. And now we're looking at the probability of x being less than or equal to 0. Okay. So it's just a case of putting in all of the different answers to see what we get. So on 0, there we are, 005. Now, 0051. Okay. Now, we need to find, coming back up here, critical region for two-tailed tests as defects. We need to look for the closest to it, okay? And when we look at this one here, where we looked at x is less than 1, okay? When you do, get my calculator back working, when you do 0.0337 take away 0.025, the difference between them is 0.0087. Whereas when you do the difference on these two here, okay, the answer is 0.0051 take away 0.025. It's 0.019. Okay, 1% versus 0.8, closer. Okay, so although this one of x being less than 0 is correct, this one is closer. So I am going to be taking that as my lower bound, okay, for my critical region. Now then, as we look for the next part, we need to look for the top end of this. Now, instead of putting it all into the calculator or writing it all down like I did that one, I'm just going to look at it on the calculator and see what we've got. This calculator is quite nice. It draws us the shape there, and it can also put into it, can actually do the bounds on it, but we can go for the upper bound here, okay? And we need to find an upper bound here that is as close as we can make it to the 2.5%. Okay, so looking at that, probably somewhere around 9-ish will be about right. Okay, 9 gives us 5.7%. Let's just see what 10 does. Okay, 10 is 0.24. That's the one we want. Okay, so when we put it in as a probability of x greater than 10, let's have a look. Where's it gone? Probability of x is greater than or less than 10 is equal to 0. What was it? 0.245. 0.245 is less than 0.025. So we'll take that one as well. So we can put them in and we can say bounds are. So we can say critical region is x less than or equal to 1 and x greater than or equal to 10. Okay, so that's part A. So if you have a quick look back on this calculator, because it can do the bounds and we can put it in, okay, here we are. Okay, so it gives us the two options, and we can put in 1 here, and we can put in 10 here. Go okay, and you can see there that it's coming in at the 9.8, which gives us the percentage. So the next step on this was asking us for what is the actual significance level of the above test. The actual significance level of the above test is going to be taking the actual percentages that we've got and adding them together. So for part B, the significance level will equal 0.0337 plus 0.0245, and that should be 245 is an actual significance of 0.0582, so 5.82%. Okay. Okay, let's go and have a look at part C to this question. Okay, a lot of work in that. Another sample of 20 articles is taken at a later date. 4 articles were found to be defective, so we need to reset up our binomial. Okay, and we will put in x binomial, and we had a sample of 20, I think it was, yes. Okay, and we're still working on the 0.1%. Okay, so with that in, where was it? Lost it. There it is. Right, test at the 10% significant level whether or not there is evidence that the proportion of defective articles has increased. So we are doing a null hypothesis, and again, it's the probability is equal to 0.1. Then we're doing an alternative probability that the probability has increased, okay, from 0.1, and we are testing at 10%, which is 0.1, and this is a one tail, okay. And they want to know whether it's the sample where there was 4. They said there was 4 articles increased. So with the probability that x is equal to or less than 4, okay, we need to look at 1 minus the probability of x being less than or equal to 3 is less than 0.1. 1 minus, let's go have a look at the calculator, where are we? So go back, change our number of trials to 20. Okay, we're still on 0.1, that's fine. And we are now looking for this one here, yes, of being 3. So 0.867, 0.867 is less than 0.1. And 1 minus 0.867 is, of course, 13%. 0.13 is less than 0.1. It is not. And so the standard sentence comes out because it's not there is not sufficient evidence to reject HO. So the how were they wording it in the question there? So the defective articles has increased. The proportion of defective articles has not increased. So the proportion of defective articles has not increased. A long question, that one. Okay. Lots of bits in it, lots of work in it, lots of points in it. Okay. So we accept HO that the probability is still 0.1 because we were way out there. We could go back and have a look at this with the calculator and just see at what point would we have needed to get it. Well, let's just change this over to a doing it so we don't have to do the one takeaway option on it. And as we come through here, if we had have had 5, 0.4, okay, that's definitely less. The 4 was 13. So if there had been 1 extra article in that sample, then the result would be different and would say it would have increased, okay, the proportion of defective articles. That's all for that one.